Hello everybody and welcome to our CS410 project, the PiazzaBot. My name is Joe Salinas, along here with Wilson Chaney, Kush, Mittal, and Rohit Sarathy. So what is the PiazzaBot? The PiazzaBot is a tool meant to assist students in getting answers quickly when TAs can't act fast enough. It uses data from previous semesters in order to give quick and useful solutions to various problems. These problems could be past questions that have been answered and have recurred in this semester, or they could just be new random questions. It compares current questions and matches them with previously asked questions with known potential solutions.
Hi, I'm Kush and I'm going to talk about the motivation behind this project and why we decided to implement this. Basically, we love the idea of how most classes at the U of I use Piazza as a forum, and we basically wanted to make it better for students. As a course assistant myself for CS125 for several semesters, I've noticed that a lot of people ask this very similar questions throughout multiple semesters, and also that a lot of TAs have similar answers to those questions over the course of many semesters. So this kind of gave us the idea that we could simply have a program that would match these questions from students to answers from previous semesters and basically make this process a lot faster for the TAs and have students have their questions answered really fast.
The first step that we decided we needed to do was gather training data. So each of us went to a previous semester where we all took the same class, in this case CS125. We went online and found a little useful Piazza API to help develop a crawler from scratch. The crawler goes through every Piazza question from previous semesters and it saves it along with the best answer associated with it. Now with the best answer, there was sort of a hierarchy on Piazza of which was deemed the best answer or not. It started with the instructor answer, then the student answer, which could or could not be endorsed, as well as other follow-up questions. So what we needed to do was parse that information and figure out which was the best solution. So in our case, our hierarchy is as follows on the screen, where we chose the instructor answer first, followed by the student answer, and then so on and so forth.
Here's an example of the data that we downloaded from Piazza. If you look at the properties title, question, and answer, those are exactly what we scraped from the page. And then we also have the cleaved versions of them, which is after removing HTML tags and other extra characters. So we stored this data in JSON format initially, along with IDs for each question, and we also stored the timestamp. This isn't the exact format that we used it when we accessed Meta. We actually just sent it the questions, but this is how we stored it in Python.
Our usage of Meta, basically we passed Meta a corpus of documents, which was, like Wilson mentioned, comprised of questions only. And using the results returned by Meta, we had, with the doc IDs, we returned a title, the associated question, and the answer to the front end. A little bit about our application development. We used the Python Flask web framework as an MVC, and here we have a Bootstrap cover page which sits on top of the backend. We used a jQuery plus Ajax request and passed that to the Flask backend, which interacted with Meta. So here we can see this in action. I passed the query drinkscraft login, and we have a few helpful questions returned from the Piazza data. Another programming question we can ask was in 125 a method count grandchildren. And here we have some helpful answers to how to implement the count grandchildren method as well. One problem that we faced with our application development was that when Meta found the answers to the query that we had, it returned a truncated response. So the full verbatim answer to the question would be truncated after a certain length of characters. So what we had to do instead was fix the JavaScript so that it would print out the full pretty JSON output so that you could get the entire verbatim question, which was a lot more helpful for the user.
One additional idea we had was to actually build a classifier so that we could classify those Piazza posts as either course-specific or pure programming. To clarify what that means, a course-specific question is something like when is MP1 due, or when is the exam, or where's my discussion, and a pure programming question might be some error that someone encountered that many programmers, even outside of this class, have likely encountered. The reasoning for this is that those course-specific questions are probably best queried off of past Piazza data, whereas pure programming questions could actually be queried from Google or Stack Overflow. The process of classifying this had a couple of steps. The first thing we had to do, which was really tedious, was to manually label a few hundred Piazza posts and we had to label them as either course-specific or peer programming, like I said. After labeling them, we had to convert that text into something that would be more useful for a classification program. So we had to clean up the text by converting it to lowercase, removing non-alphabetical characters, removing stop words, and stemming the words. And the reasoning for doing that is because after cleaning the text, you could convert it into term frequency vectors. The dimension of those vectors would be the number of words in the overall vocabulary, which is every unique word across all of our labeled posts. So generally, the term frequency vector for a post would be something like a 2,000 dimensional vector, and almost all of its elements are 0. It just has a couple 1s or 2s depending on which words do occur. And then those are the vectors that we use to train a naive Bayes classifier. And in the same way, to test it or to use that classifier, you could take a query and do that same cleaning process, convert it to a vector, and then predict with the same classifier. So here's a really interesting graph we had while developing the classifier. On the x-axis here is the number of examples that we used to train it, and on the y-axis is the accuracy on test data. So we held out about 20% of test data, and then we used about 320 labeled posts to train. I actually averaged these results across a bunch of different runs, so this is pretty consistently what we saw. So you'll notice that after about 90 examples, the test accuracy tends to level off, which we found really surprising. Essentially what that means is that you can't get any more meaning beyond 90 Piazza posts. So our classifier really just used those first 90, first 100, and the rest of them were superfluous.
Given the limited amount of time that we had this semester, we basically implemented this project as a proof of concept and not an actual program. But where could we go from here is we could basically implement this in real time. When a student asks a question, we could actually post the answer to Piazza itself so that the student could get the answer right away. Another thing that we could possibly do is, based on the classification link, the programming questions to Stack Overflow to give a better answer to the student.
X gon' give it to you. Wait for you to get it on your own. X gon' deliver to you.